We're spending another day learning about the definition of derivative, and on the last day that we were here, we started this example, and we said that we were going to use the definition of derivative to calculate the derivative of x squared, then use that derivative to find the slope of the tangent line to the function at x equals 2. Well, what I told you is that we always have to start with the definition of derivative, which is right here. The limit as h approaches 0 of f of x plus h minus the function all over h. So the very first thing that we have to do is find this. We need to find f of x plus h. All right? Well, my function is x squared. So f of x plus h is x plus h, the quantity squared. So we need to use, I started to write, FOIL to do that, or the square of a binomial shortcut that I showed you last year. This is the same thing, and be careful with this. If there's one place where you can make a mistake, this is it, foiling something. This means x plus h times x plus h. And doing FOIL, that is x squared plus 2xh plus h squared. Be cautious with that, okay? There are so many algebra errors that calculus students make, and it winds up really frustrating them later. So don't get in a big hurry and get sloppy with that. It'll tick you off later. So going back to my definition of derivative, I now know what f of x plus h is. So I can put that in right there. Okay, so now I have, I'm going to draw a line. I now have the limit as h approaches 0 of x squared plus 2xh plus h squared. That's what f of x plus h is. Okay. Now I need to subtract just the function. So what is the function? X squared. Very simple. And all of that needs to be over h. Now, for the most part, a lot of the times, what's going to happen is some stuff is going to cancel out. Get out the slasher. And you're going to be left with an expression that has some h's in it. All right, look at what I have left. I now have the limit as h approaches 0 of 2xh plus h squared all over h. And we can simplify that. So I'm going to go to a new screen. 2xh plus h squared all over h. And this is the limit as h approaches 0. So let's do some factoring on top. Okay, on top I've got an h that I can pull out. So I have h times the quantity, 2x plus h, all over h. This is still the limit as h approaches 0. Slasher. And I now have the limit as h approaches 0 of 2x plus h. Now can't I do a simple substitution to evaluate my limit? If I plug in 0, this is going to be 2x plus 0, which is 2x. All right, this is the first time we have seen this. That is called the derivative of x squared. Okay? This is, we would say that this is the derivative of x squared, 2x. Now it has a notation, which is f prime of x. F prime, that little kind of apostrophe, whatever you want to call it, we say f prime of x. That is the notation for derivative. Okay? But there's a bunch of names that we give the derivative, and here is I think, the most important one. I think the most important name for the derivative is the general slope function. The general slope function. This derivative, once we find the derivative, okay, and we now know that the derivative is 2x, it will allow me to calculate the slope of the tangent line anywhere to the function. Let me illustrate. Here's x squared, okay? Now what did our question ask us to find? Didn't it say find the slope of the tangent line when x equals 2? So when x equals 2, okay, here's 2, we want to know what is the slope of a tangent line right there. Well, once I have the derivative, my derivative is 2x, which is the general slope function, then all I do is I plug in the x value there. F prime of 2 is going to be 2 times 2. Isn't that 4? Everybody follow me? That is the slope of this tangent line right there at that instant. Okay? Now, what if I wanted to find the slope of the tangent line when x is -3? Plug in -3, that is correct. So I would, what am I looking at? I'm looking at the slope of this tangent line. Now what does common sense tell us? Should that slope be positive or negative? Negative. Should be negative. So if I use f prime of x equals 2x, if I use my general slope function, I do f prime of -3, which is 2 times -3, which is -6. That is the slope of this tangent line at that instant. That is the instantaneous rate of change at that instant. It's how fast the function is changing right here. Okay? And that is what the derivative allows us to calculate. And this is what Sir Isaac Newton, you'll hear me mention him a bunch this year, he developed the concept of the calculus to explain physics. So right now, if you are in physics class and Mr. Weaver is wanting to use calculus-based physics, it's for a reason. It's because Sir Isaac Newton developed the calculus to explain real-world phenomena. Let's just say he was a genius. Okay? So, tonight you're going to have to do this. You are going to be asked to calculate, number one, the derivative of f of x equals x cubed. Number two, I guess I don't need to write find since I've got calculate up here. F prime of 3. And number 3, what does f prime of 3 mean? Remember I told you that we are going to do things, we're going to verbally nag. We are going to have to be able, with words, to explain what we're talking about. So, let's get right to it. What's the first thing we should write down? Our definition of derivative. You're going to do all of these with the definition of derivative. So we start with f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. You will learn that real fast. So the first thing I need to find, remember, is f of x plus h. Well, if my function, and I don't mind if you kind of come over to Rivendell and do this work. If f of x equals x cubed, then f of x plus h means x plus h, the quantity cubed. And please, I beg thee, don't do this. That is not right. Large scale frowny face if you make that mistake. No, no, no. This is as long as you think it is. We need to do x plus h times x plus h times x plus h. The good news is, didn't we kind of work through this on the last one? X plus h times x plus h. That is x squared plus 2xh plus h squared. Now, I just need to multiply that by x plus h. Be very cautious with your algebra here, because this is where so many people make a mistake. We now need to carefully distribute by multiplication the x to all three, and then distribute by multiplication the h to all three. Okay? The first part of this is long. That's just the way it is. So when I do that, okay, I need more room. I have x squared plus 2xh plus h squared, and I'm distributing x plus h. So when I distribute the x, boom, 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 I have x cubed plus 2x squared h plus xh squared. When I distribute the h, boom, 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 I have x squared h plus 2xh squared plus h cubed. Now, that is just f of x plus h, but can't I simplify it a little bit? I have a like term here and here, okay? And I have like terms, so those two, and I have like terms here and here. So I now have x cubed plus 3x squared h plus 3xh squared plus h cubed. Now we need to kind of come back to our definition of derivative. We have now found this is my f of x plus h. But remember, I need to subtract the function. So I just put minus x cubed. Okay, because my function was x cubed. That whole mess is over h, and I'm doing the limit of this puppy as h approaches 0. Yay for us, we can get out the slasher. And I know that these problems are long, so if you're careful, we can go straight to where we pull out an h. Do you see that I need to pull out an h? So I now have the limit as h approaches 0 of h times 3x squared plus 3xh plus h squared all over h. Get out the slasher. And slash away. And now I have the limit. We're just about done. Hallelujah. I have 3x squared plus 3xh plus h squared. Now I just have a straight polynomial, so I can go straight to substitution. I can plug in my 0, and that's going to give me 3x squared plus 3x times 0 plus 0 squared, which is just 3x squared. 3x squared is the derivative of x cubed. It is the general slope function. It will tell me the slope of the tangent line at a certain point. Okay? So let's go back to what we're supposed to find. Find f prime of 3. Isn't that going to be easy now? This is going to be easy. So now, to find f prime of 3, we can go to a new page. If f prime of x is 3x squared, then f prime of 3 is 3 times 3 squared. That is 27. So we've done the second part. I'm probably as concerned about you getting the answer to question 3 right as anything. Question 3 said, okay, what does f prime of 3 mean? Very good. It is the slope of the tangent line to f of x when x equals 3. That's one way we could say it. Okay, that's one way. We could also say it is the instantaneous rate of change of x cubed when x equals 3. Okay, that's another way that we could say it. It's the idea that we can calculate how fast a function is changing at a given instant. What is the other name that I gave to the derivative? The general slope function. Because remember, I can calculate the slope of the tangent line anywhere once I have the general slope function. All right? Okay, we need to do one more example, like you're going to see in homework. Find the instantaneous rate of change to the position function at the given time. All right. So what they're going to do is they're going to give you a position function, s of t equals, I'll use an easy function since we just did a hard function. Let's say that I have 5t minus 8. Okay, let's say that that is my position function. Okay, what do they mean by position? By position, they mean this function right here is telling me where an object is located. This is going to be so huge within a few weeks as we start moving into velocity and acceleration, to understand that this position function tells me where I am or where an object is. What do I mean? Just watch very simply. Let's say that the time was 2 seconds. At 2 seconds, I could say that this particle or this object is located at 5 times 2 minus 8. 10 minus 8, it is located at 2. Okay? And then, right, y equals 2. But then I could find out where is it at several seconds later. Okay? Like, where is it at when I'm at 5 seconds? Well, then I would do 5 times 5 minus 8. 25 minus 8 is 17. So now it's located at y equals 17. Okay? But that's not what this question is asking. I'm just helping you understand this idea of a position function that tells me where I'm at. Now, yeah, if I'm asked to find the instantaneous rate of change to the position function at the given time, and I didn't give you a time yet, let's say that they tell you at time 4. Well, if I'm going to do that, then I have to use the definition of derivative. I have to calculate the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, fortunately, this is an easier function. Okay? This function is 5t minus 8. Okay, that is my function. So if I wanted to find f of x plus h, then I just have 5 times the quantity x plus h minus 8. This one's a lot easier. I just do the distributive property, and I have 5x plus 5h minus 8. So that is going to go right here. So now I have the limit as h approaches 0 of 5x plus 5h minus 8 minus the original function. Now, don't get caught up in t's and x's. I mean, if you by accident start working with x's, just keep using them. So now I need to subtract carefully. I'm going to use an x. 5x minus 8 all over h. So now I have 5x plus 5h minus 8 minus 5x plus 8. Okay, that whole thing is over h. Yes, I can slash some things. I can slash the 5x's. I can slash the 8's. And I'm left with the limit as h approaches 0 of 5h over h, which I can slash again. And I'm left with just 5. And guess what? That is the derivative. This is s prime of t. I wonder why there's no t or x. Very good, because it's just a linear function to begin with, right? Look at my original function. It's linear, which means that everywhere, it was 5t minus 8, so down here it's negative 8. It's a linear. The slope of it everywhere is 5. No matter where I'm at on this line, the slope of it everywhere is 5. Now notice something. That won't always be the case. You do have a derivative here. S prime of t, we found out, was 5. So weren't we supposed to calculate the instantaneous rate of change at, what did I say, 4?
5.
It was at 4. So I need to find S prime of 4, which is still 5. The reason I'm showing you that step is because some of your derivatives tonight of the position function will still have a t in it. And so you may have to plug in the value. Okay? So don't forget, you technically have to plug in the time into the position function. And we're going to stop there for today.